Right. So it is time to get started, which means that I need you to get your brain in physics mode. I wanted to say thank you again for Friday. I know that Friday we did a lot of stuff. There was a lot that was going on. You guys did a very nice job of staying focused, and I really appreciate that. It's going to make what we do today go much more smoothly, I believe. Okay? So let me just remind you what the plan is for the day. First is just a reminder, corrections on the Unit 1 test. I think that we talked about this last time, but just to be clear, if you would like to make corrections, you are welcome to come in during Liberty time today, or tomorrow or Wednesday. Or if you have a free period sometime, I know that people are planning like 7th period. I'm also free 3rd. A lunch is open. If none of those work and something else works for you, let me know so that we can make arrangements. I would like for you to get that done this week if at all possible, just so that they're not hanging out and, just hanging over your head and I don't have to wait for them, all that sort of thing. I did want to also let you know that I did finally put some grades in, and I apologize for how long that took. But, when you're trying to plan, that's my number one priority always. So they should be up to date. A couple of things, a couple of the labs, when I was looking at them and kind of how things balance, I cut the score in half. So like that bouncy ball lab was originally out of 18 points, which is like a lot of points relative to the other labs. So I put it in as 9, and then I just split everything in half. So if you look at that, make sure that you look at the total also. But I would ask that you go through and look tonight or tomorrow, not right now. Please put your computers away right now. You do not need to do it right now. But sometime in the next 24 hours or so, go over and look and see, just to make sure I didn't make any silly mistakes, because I absolutely don't want to cheese anybody out of points. I want to make sure that things are accurate. I did have a situation this morning where I put some scores in for my earth science kids, and I accidentally typed something totally wrong. One of my students was like, "My dad was yelling at me this morning," and I felt really bad. I never ever intend to do that, but mistakes happen, and I own that. So anyway, please check that. Today we're going to go over homework. We got to finish that mystery box problem that we started on Friday, and then I'm going to give you some problems to work it's kind of a fun set of problems. So that's where we're going to go today. Questions, issues, or concerns right now? There was one question that I heard earlier, which was, do we have homework tonight? And the homework is to finish this applied problem. So if you do not finish it in class today, you will do it at home for homework. So you don't have any book homework tonight. Okay? All right, so it has been ages since we've gone through homework. I think, since the last test. So these are the problems that I believe have been assigned. Are there any of those that you all would like to go over? I'm open to things, but I do want to ask that everybody pay attention, even if you think you got them, so that we can make sure that everybody's feeling good. I was going to say, I don't have numerical answers. I'm going to get access to that this week. I just don't have it yet. But let me know if you want to go over anything. So, make it look like you had your hand up.
Number 24, it's like the same kind of problem as the one we were working on in class.
The chapter 5, number 24 one? Yeah. Let me take a peek at it, and I might say we'll wait until later, but let me just look at it to make sure. 24. The bicyclist, is that the one? Bicyclist rides down a hill with a 3-degree slope. He attains it. Oh, that's not it? Oh, it's not. It's a problem. I'm sorry. This is why I read them out loud. So you're like, no, stop. Oh, the goat.
Oh, really?
Mountain goats can easily scale. Yes. The problem we're going to finish will answer this question. Is that okay? Okay. What else? Anything else from the homework that you would like to go over with me? This is your opportunity right now. Elizabeth, what you got? Chapter 5, question 9. I'm going to look in the question section. The sledding one? Is that right? You're like, yeah, I think maybe. You are going sledding with your friends, sliding down a snowy hill. Friction can't be ignored. Yeah, so riding solo on your sled, there's a lot of chitter chatter, and it's really hard for me to stay focused. So please, shh. Riding solo on your sled, you have a certain acceleration. Would the acceleration change if you let your friend ride with you? So let's look at how that's going to, can I come back to that one right after we finish this question? Does that sound okay? Or did you have a more specific piece to it?
No.
Is that okay? because I think it'll help. I think it'll help. Once we've really looked at this incline problem, I think it'll help. Yeah. And I'm not trying to just like defer questions. I just think, yeah, the one we're going to do will solve a lot of that. Anything else? Go.
Can we do problem 34, chapter 5?
Problem 34. Yeah. Or I'll say we can wait. Yeah, but let me look. Yes, we can look at problem 34. All right, chapter 5, problem 34. This is the one with the vendor at the local art fair. Is that right? Ties her tent down with a concrete-filled coffee can. Stiff breeze comes up and the string becomes taut. What is the maximum value of the string tension before it will slip? Okay, so here's my coffee can. Oh, you can't see my pretty picture yet, huh? Let me allow you to see my pretty picture. Huh? Is that pretty? Isn't that nice? And there's a rope that's coming off like this at an angle of 40 degrees. So I'm just gonna go ahead and label that as the force of the rope on the can. What other forces do we have acting on the can? What's that? I heard lots of mumbles. What did you say?
Friction.
Friction. Yeah, which way is friction going to act in this case? Horizontally, this way? Right? So the force of friction, force of the ground on the can, FF. We know it's there because it tells us the coefficient, right? That's nice. What else you got? Other forces acting on the can? What'd you say?
Earth.
Earth? Which way does Earth go? Down. Cool. Anything else? Normal force. Normal force going up. So the force of the ground on the can, Fn. Okay. I drew a Freebody diagram. Go me. What are we trying to figure out? What's the question?
What's the maximum force that the rope can?
Yeah. What's the maximum force that the rope can have before it overcomes friction? Right? So we need to find out something about this one. We've kind of talked through this a little bit before, but let's see here. What do we do after we have a free body diagram when we're trying to solve a forces problem? What's another good thing to write down? F-net equations. How many are we going to write? 2, because usually, unless it's a one-dimensional question, we write 2 down. So here we go. Let's write an F-net in the x direction. And then we'll also write an F-net in the y direction. Let's do the x one first. Who can give me something acting in the x direction?
F ground on can.
Say what?
Force friction.
Force of friction. I just couldn't understand what you said. Sorry, I was just like really confused. The force of friction, the force of the ground on the can. Absolutely. Yeah, we can break this one up into 2 pieces, right? So we're going to call this the force of tension or the force of the rope or the force of applied or whatever you want to call it, but it's just the part in the x direction. And we're looking for just that breaking point, right? That threshold. So what do we really want x to equal? We want it to equal 0. We're looking for the maximum where it can equal 0. Oops, that's a really fun looking 0. Let me try again. How about in the y direction? What are my forces in the y direction?
Earth.
You know, to a class, there's always one person. I can never predict who it is, like when I first meet you all, but there's always one person who starts doing that. I'm just letting you know. So Henry, you're the person. So good for you. All right. FG. No, like I said, it's not like something that I can predict from year to year. All right, FG. What else you got that's pulling up and down? F what? FN. Anything else? Applied force of the tension force in the y direction, this part, right? We call that Ft sub y. Equals 0. All right. What are we going to do now?
We can find FG.
Can find FG, absolutely can. Because we know that the mass is 3. So I'm going to go ahead and write that down. I like that. So FG equals the mass times the acceleration due to gravity. So that's going to be 3 kilograms times 9.8 meters per second squared. Somebody's going to tell me what that is. Huh?
29.4.
Thanks. Cool. And this one goes down, doesn't it? And these two go up. I'm just going to make that negative right now, just so I don't get confused. Or I can put a negative here. I just need to make sure that I know that it's going, this one's going down. And these two are in opposite directions. I'm going to go ahead and put a negative sign next to that force of friction. That's a good question. I like this one. Now what?
I already did my part, so
Done and done.
it's all you guys from here on out, guys. Come on now. I know I'm not the smart one.
You are a smart one. Any ideas? I mean, I like it when you figure it out. We've got some really, like, the brain power in this room is pretty intense. All right, Ian, get us started.
Did it say something about static friction?
It said that the coefficient of static friction between the can and the ground is 0.6.
So what may be hidden through the static friction? It's less than force of static friction is less than or equal to the coefficient times force.
Are you guys listening to what this very smart comment that's coming out of this corner? Say it again.
So they gave you the coefficient for the static friction.
Yeah.
And you need to figure out the force of friction by using the coefficient of the force, or finding out the force.
Yeah. We remember, hopefully, or we can look it up, or we can tell ourselves that FF, remember, is less than or equal to, but we're looking for that threshold where it equals, right? Mu times Fn. Does that make sense? Okay. So we can even put that in here if we want. Should we do that? Make our life a little bit better, maybe? Negative mu Fn. Well, and it has to really equal, doesn't it? Like, these two really have to be equal if they have to add up to 0. Can I just do that? That'll make my life even a little bit better. Tell me if I'm skipping too many steps and you're getting mad at me. How are we doing? Are we okay? What now? These problems are funny because it's not just one way to do it, right? You have to just kind of like squish things together and smush them around and see what happens.
Can we figure out the triangle using the cosine to get FTS?
For sure we can. Absolutely. Do we know what the tension is?
No.
That's really what we're trying to figure out, isn't it? Yeah, what is the maximum value of the tension? So Ft is the thing we want to know, but we can write this as Ft times the cosine of 40, right? And we can write Fty as Ft times the sine of 40. Sorry, that's kind of little because I was trying to squeeze it in there. So we could write that. I like that idea. So let's do that. Let's write down, this is going to be equal to Ft cosine 40. And oh, I guess I could write this one too. So I've got that thing, that Fg plus Fn plus, so that's really just Ft sine 40. This is the same process as you guys do in math. It's a system of equations, isn't it, guys? That's really all it is. And I know you all love systems of equations. But really, now we're just going to kind of see how we can fit this and this together. We're going to mash them together and see if we can solve. What can I do to put this stuff together? Any insights? Any ideas? Do you want me to let you play for a minute, or are you like, I'm not really sure what to do next? Is that how you're feeling? It's okay. These are good questions. I love these. Do we know FN?
No.
No. We've got FN in two things, right? Do we know FT?
No.
No. We've got it in two equations, right? Two equations, two unknowns. Can it be solved? Yes, it can. Okay. So this is what I'm thinking. Let's solve this thing for FN and just throw that nastiness right in here. Are you with me there? Is that okay? Let's do it. It's going to be ugly for just a minute. So we're just going to take a deep breath in and let it out. And we're going to do it. It's going to be awesome. Here it comes. Here it comes. I'm excited. FN is equal to, that's going to be FG minus FT sine theta, or sine 40. Is that okay with everybody? What I just did there? Because FG is going to become positive?
What is that? Oh.
Because it was negative over here? Is that okay?
No.
Now I'm going to throw this mess in here and then things are going to cancel and it'll be beautiful. I believe it. I've never done this problem. I'm kind of excited about it though, not going to lie. Mu times this big nastiness. Oops, I keep wanting to write theta. I'm going to write theta. It makes me happier. It is 40. How many unknowns do you have in this thing?
1.
I feel like we're like in communication today. I love it.
In sync.
Can you solve it? Yes, Miss Carbling, you can. Go. You do it. You do it. Move your pencil.
It's in the bag.
Get your brain started. You got this.
I'm gonna carry the bag for this table.
Solve for FT.
I'm in my
You might need to distribute that mu.
You would distribute it.
Oh, yeah. I got that. Mu is what,
What do you
0.3?
think came first? You, this, or you?
0.6. Mu is 0.6.
How do you spell mu?
MU. So it's kind of like, how do you spell a letter, right? But linguists can tell you how to spell a letter. Every letter in the Roman alphabet can be spelled with other letters in the Roman alphabet. It's weird. Look it up, but not right now. Do this. I know, right? It's good stuff. Linguistics is crazy cool. So I'll tell you the joke after these problems. Don't let me forget. Did you solve it? Talk to your table mates if you're like, I don't know what to do. You want to get all the FTs on one side, all the not FTs on the other side? Solve it for FT. You got this, guys. You can do this. Don't wait for somebody else to do it for you. You do it for yourself.
You distribute mu.
I would distribute your meal. Yeah. Look at you. You're on fire today. You can say that.
Is equal to FT cosine theta. You can find it.
Number minus number.
Do what sine 40? Get your calculator out.
Bree, you're gonna need it.
I don't mean that in like a sometimes it's really just you can get over
Oh, that happens to us.
So did you get my green?
It's not. How is it better?
You got number minus.
Dropping down to me. We know what FG is equal to.
Sign for
No,
So then you really got number minus number times that makes sense. You rocking it still?
Yeah, I got it.
Are you rocking it?
I'm watching.
Don't watch it. Do it yourself.
I didn't try that. Oh. I'm worried about what I got on Anthony too, so. What's the name?
Yeah, that's the one I did.
How are we doing?
Yeah.
Ian, are you happy? Happy? Awesome. How are we doing over here? 29.4.
I'd go for
Yes.
Oh, we know.
That one too.
It's literally just algebra.
Yes. Good for asking. You gotta ask this always, because otherwise you're like, sure. How are we doing? Did we get an answer?
Please don't make us do that again.
Yes or no? What did you get? Do we agree on an answer? 15.2? Do you guys agree with that? Some rounding happening about 15.2? Or totally no?
I don't even know what's happening.
Okay.
Sorry.
That's okay. All right, let me back up real quick. And then I'm going to answer Rihanna's question for everybody because I think it is important. Okay? But I want to back up here real quick. So you're going to distribute your mu, yeah? Everybody did that?
Yep.
Mu is a number, 0.6. FG is a number, 29.4. Sine of 40 is a number, right?
Yeah.
You plug in, it's a number. So you've got number minus number, FT, equals number, FT. That's really all it is. Then you're just plugging through and chunking through and you do it, okay? Now, in her eternally positive and always optimistic way of asking questions, which I appreciate, Brianna said, why does physics always take forever? Or so, what did you say? I don't even remember. Was it that positive? No, it wasn't. Why does this always take so long? It's a good question. So here's the answer. You have to get it set up, right? Here's the thing about AP Physics 1. That's what class you're in, okay? On an AP test, on an AP-like test that I would give you, I am not going to give you this problem. I wouldn't do that because this is not what you're getting ready for on the AP exam. That said, so people are like, why do you do this then? Because for you to understand the underlying what's going on, you need to see the process. Not 20 times. I'm not going to give you 20 of this problem. I'm going to give you 1 or 2. Because I want you to understand how it works. The things you will see on an AP exam. Drawing a Freebody diagram. Absolutely. The things you will see on an AP exam or on one of my exams. F-net equations. Determining how these things are related. A question might be asked, as the wind picks up, how does the tension force, like what happens to the tension force? Are you with me there? Does that make sense? Or how would you know when it would start to move? The way that you learn that is by seeing it and doing it. The stuff I would say from like here down, this is math. We're just using math to solve the problem. This is not what your AP test is going to be on. That's not to say that's not important, but that stuff is not what I'm most concerned about. Does that make sense? So I don't want you to stress about this, but I also want you to feel empowered because you totally can do this. Even if you're not in like the BC Calc or whatever, you can still do this, right? I just want to make sure that makes sense. Are we okay on this problem now?
No.
Who's saying no?
Is that the right answer?
I don't know.
It's like 15.3.
15.3-ish? Sure. Are we okay? Okay, I'm going to move on. I want to come back to this question. This is what we ended with on Friday. Do you remember this question? That silly mystery box. What's that?
Restart it.
We are, right now. Here we go.
No, we are.
Well, I'm not going to retry, but I'm going to remind people because it's been a long weekend. I don't know about you, but I was not thinking about things on inclines the entire weekend. I don't know. Maybe you were. And if you were, by all, that's awesome. But, all right. No judgment. I mean, that's cool. All right. Stop talking, please. Friendly reminder. The question says to determine the normal force acting on the mystery box while it's sitting in a ramp at a 25-degree incline. The question says what other force must be acting if it's at rest? So we got to drawing a free body diagram. Just friendly reminder of what was happening here. You told me that there had to be gravity pulling down. Gravity always pulls what direction, guys? Straight down towards the center of the earth. Straight down. That was that red line that we drew. Okay? There's a surface, which means there's got to be a normal force. Normal means what? Perpendicular. So it's going to come up perpendicular from the surface. That's kind of weird. I asked you, and you told me that there had to be some other force acting, and you decided that was a force of friction, holding it up, because otherwise it's going to slide down. Bless you. Okay? Friction is always parallel to a surface. So I've got these two forces that are perpendicular to one another, and then I've got this gravity that's at like a funky angle. That's annoying. Okay? But then we're like, oh, we could break this down into a perpendicular and a parallel. And so that's where we stopped, and then the bell was going to ring and whatever, we decided to stop. So now, this is almost exactly what you're going to do on the apply problem that comes next. So I want you to make sure you're staying focused when they boom right now, okay? So here we go. A little geometry for our day because we love geometry. I know you do. I know it's been a while since maybe you've done it. But we're going to do some little geometry tricks. Here they come. So let's see. I'll draw this on here. If this is 25, this angle here, right here is what? 90. What's this angle here? 65. Yeah, we can write the proof for that, right? Yeah, do you guys do column proofs? I'm not going to make you do it right now. But you remember that, right? Okay, now here's another question for you. What's this angle right here? This one here? 90, because this has to be perpendicular. We defined it as perpendicular, right? So this is perpendicular to the surface, so that's got to be 90. So then we're going to use our sum of the angles on a straight line has to add up to 180, right? Just like it does in a triangle. So what does this angle here have to be, friends?
25.
Boom, there you go. Now, do you have to write out that proof every single time you do an inclined plane problem?
No.
Absolutely not. Just today. Okay? It's beautiful. The nice thing about this is then we can figure out what FG perpendicular and FG parallel are. FG perpendicular is just going to be FG times the cosine of theta. So in this case, the cosine of 25. You with me there? Is that okay? This guy here, right here is theta. And FG parallel is going to be FG times the sine of theta. Are we doing okay? Is this making sense? I don't want to go too fast, but I also want you to be able to see it. Given that information, you should be able to figure out the normal force. Okay? Given that information, you should also be able to figure out this force of friction. And given that information, you should be able to figure out the coefficient of friction as well. What? That's awesome, right? Well, maybe not the coefficient of friction. We'll talk about that in just a second. It isn't, but we don't know if it's just barely not moving. I forgot that I left that little bit out. The box is not moving.
Are the mystery box problems like
Yes, they are. Yeah. Let's write an F net equation. F net, let's do parallel. Or no, it's perpendicular. Let's do perpendicular first. F net perpendicular. What's acting perpendicular to the surface, friends? Normal force. What else? Boom. They have to add up to what? Because it's not what? And in fact, more than not going up or down, it's not, it starts with an A, not accelerating. There you go. Can you figure out what FG perpendicular is? That's going to be the mass. Oops, so that's 10, right? Kilograms times 9.8. We're doing 9.81, I can't remember. 9.81 meters per second squared times the cosine of 25. Y'all can plug that in, right? Is that okay? And you already plug it in. Do you already know the answer? For FG or for FN? 88.8? Okay. Do we trust him? I don't know. Do you guys agree with him? Is that what you got? Oh, no?
I trust that. I trust that fully.
What did you get? Oh, ouch. Oh, that was silly rounding business. Are we okay? No?
Why is it actually perpendicular?
It is. It is. I'm just being lazy. You're right, though. It should be. Because they have to add up to 0. Yes. Is that what you're asking?
So then it would be difference.
So Fn and FG perpendicular have to add up to 0. The value of FG perpendicular is going to be this. It's just going to be in the negative direction. Does that make it different? How so? I guess maybe I'm missing something. Because I've only got two things. I've only got Fn and FG perpendicular that are acting in that direction. And so whatever this is, Fn has to be the opposite of it.
So FG perpendicular is equal to negative 98.1 sine 25.
Correct. Cosine.
Cos.
Yeah, because it's the adjacent leg. That would change it. There you go. How are we doing? Are we okay? Can you figure out what FF is? So this is going to be F plus negative FG parallel. Those are adding to 0 because it's not accelerating, because it's not moving. So FF equals mg sine theta. What do we get for an answer for that one? Something awesome?
It's 41.6. Wait, 41.46.
So 41.5? Is that okay? Because I'm lazy. Oops, did I do that? I'm sorry.
Did I?
You were just throwing stuff through? I feel sad if that was fixed. This is your play problem.
My mom just freaking loves. I'm gonna say it.
Yeah?
I don't care that you put.
Ooh, that's unfortunate. That's an unfortunate situation to have there. All right, ladies and gentlemen.
I don't care that you broke it.
One of the things that I really like to do in physics is not to just stand up here and talk, but to allow you, give you the opportunity to do applied problems. I like the supply problem a lot. I thought we were going to do this problem a long time ago, which is why I told you to bring those little candy bars or those big candy bars. And then, like 5 days later, I'm like, oh yeah, now we're going to start it. So I got you some candy, so I'll let you use it. Okay. But before I give you the candy, I need you to make a plan. I need you to work with one partner, and I need to be a person that's not at the same table as you.
Okay, right.
So find yourself a friend. Go move around, separate yourselves, and take a look at this. Go.
No.